Hi everyone, thank you for joining Designing Fire-Resistive Joints to meet today's design. This webinar is sponsored and presented by CEMCO. My name is Tawen, AWCI's Education Program Manager. At this time, I'd like to welcome our presenter, Jaime Manzo. Jaime is responsible for sales and technical support of CEMCO's Firestop product line. His role includes technical support of CEMCO's fire, acoustic, and smoke joint products across the construction industry. Prior to joining CEMCO, Jaime spent 5 years in the industry promoting code-compliant products and training contractors on best practices. His prior experience also included providing technical assistance for one of the largest drywall manufacturers. So welcome.
Cal, thank you for that introduction, and thanks everyone for joining us today. In this session, we're going to spend some time discussing how building codes relate to fire-resistant joint systems, particularly within gypsum board assemblies. We're also going to look at how joint fire stopping has evolved over time, from a more traditional approach that many of us are familiar with to newer solutions that have emerged in response to modern building design. Now, the goal today isn't simply to review code language, but to connect that language to practical applications that you'll encounter in real-life projects. Now, before we get too far into the material, I do want to set a quick level of expectation to how I typically present. I'm not going to be reading every slide word for word, but instead I want to focus on the main ideas and expand on those concepts as we move along. So if there's something on a slide that I don't address directly, or if a question comes up while we're talking, please feel free to drop it in the chat box and we can answer it after. The objective today is really to help you move through a set of ideas that allows for you to identify, discuss, evaluate, and ultimately apply some of these concepts on your own projects. Now, some of the information may already be familiar to you, and if that's the case, it may simply reinforce what you already know. But hopefully there will also be a few insights or perspectives that are new or useful. So for today's discussion, we're going to focus on the 3 common joint conditions within rated gypsum wall assemblies: wall joints, bottom of wall joints, and vertical wall-to-wall joints. Now, these are the intersections where rated assemblies meet other building components, and they're some of the most common locations where joint fire stopping is required. So we're going to start with the head of wall condition. So in a typical building, a rated gypsum partition may terminate against either a flat concrete slab or a fluted metal deck. When we're dealing with a fluted deck, the gypsum board is often cut to follow the deck profile, in which what many of you may know as a castle cut. Now, the space of the gap between the top of the wall and the underside of the deck is what the International Building Code section 715.1 defines as, quote, joints and voids in or between horizontal and vertical assemblies, end quote. Now, fire-resistant joint systems exist specifically to protect these openings where 2 rated assemblies meet. The UL and ASTM test standards we're going to talk about today, those are designed to evaluate the performance of the joint systems under fire conditions. Now, building on this idea, when we talk about fire-resistant joints, the key requirements are going to be outlined in IBC section 715.1. This section establishes that the joint systems must be tested and listed assemblies, meaning the materials and installation methods must match an approved system design. The required fire resistance of the joint must also align with the rating of the surrounding wall or forest assembly. So, for example, in a 1-hour rated wall intersecting with a 1-hour rated deck, the fire-resistant joint at that intersection also must provide a minimum 1-hour fire resistance rating. Now, the diagram shown here illustrates several joint conditions that you might encounter. So if we're going to go clockwise, you'll have a gypsum wall meeting the underside of a deck. Below that is a floor-to-floor joint. Next is a floor-to-wall joint. And lastly, a concrete or masonry wall-to-concrete deck assembly. For today's conversation, we're going to stay focused on the gypsum partition conditions highlighted here: head of wall, bottom of wall, and vertical joints between frame gypsum partitions and the surrounding structural elements. So at this point, a reasonable question might be, why is there so much attention placed on these joints? Well, ultimately, it's going to come down to the building code compliance and life safety. Now, the IBC defines how buildings must perform based on factors such as occupancy, construction type, and intended use. Now, these requirements extend not only to the walls and floors themselves, but to the joints between them. And here's an interesting point. If you ask most people what the leading cause of death in a building fire is, the immediate assumption is going to be its flame exposure. But in reality, the leading cause is smoke inhalation and toxic gases. And what actually surprises many people is that the traditional fire resistant test historically focuses primarily on flame and temperature performance, not smoke migration. Although this is the beginning to change, smoke control has only recently started receiving broader attention in Firestop testing standards. And smoke is one of the biggest dangers in a fire, and it moves a lot faster than most people realize, traveling up to 22 miles per hour or roughly 2 to 7 feet per second, meaning a room can fill with the smoke in under 3 minutes. And so as heat builds, that movement actually speeds up, pushing smoke through any opening, such as a gap or a joint in the wall. And here's a key point. Smoke travels faster than flame, which means people have even less time to react and get out safely. And this is why controlling air and smoke movement is so important. Also, you're going to see the term flashover. Now, that's basically when everything in a room ignites almost at once, and that can happen in as little as 3 to 5 minutes. An 8,000 cubic foot room can fill with smoke to zero visibility in about 3 minutes and 40 seconds. Now, while fire is a major threat, the danger of smoke and toxic gases are just as critical, which is why they are gaining increased attention within this industry. Now, that being said, we are starting to see more emphasis placed on the need to control smoke mitigation from the fire side of a structure to the adjacent unaffected side. So why is this a concern? Well, because during a fire event, as air in the room heats up, it expands and builds pressure, very similar to how hot air lifts a balloon. Now, that pressure seeks out any available opening. So even a tiny gap can act like a nozzle, allowing hot gases, smoke, and toxic fumes to force their way into adjacent spaces. The reason this happens so quickly is due to pressure differentials created during a fire, which draws dangerous elements through any available path. And this is exactly why sealing joints, penetrations, and gaps in rated construction is so critical to prevent the uncontrolled spread of smoke and fire. Now, going back to the building code, section 715.3 identifies the test standards that all Firestop manufacturers must follow to validate their product performance in rated joint applications. Now, 2 primary standards are referenced, UL 2079 and ASTM E1966. And just a note on that, either test standard is acceptable for demonstrating compliance, and it's up to the manufacturer if they choose to test one or both testing services. And although the standards are similar, there are some differences, particularly regarding L rating, as noted under the pass-fail components. To meet code pass-fail criteria, Firestop systems must do 3 things. First, prevent passage of fire from the fire-exposed side to the unexposed side. 2, limit temperature rise on the non-fire side, commonly defined as no more than 400 degrees during the test period. And 3, accommodate movement. So most joint systems are also tested for cycling or dynamic movement capabilities. Now, if you recall a little earlier, I mentioned that the conditions where rated assemblies intersect non-rated assemblies. Common example of this would be a curtain wall. In these cases, the requirements are outlined in 715.4.2 of the IBC. Now, this section details the specific test standards that manufacturers must follow for such joint configurations. Now, a little later, we're going to discuss another important section, 1705.16, which deals with special inspections of fire-resistant penetrations and joint systems. Now, let's look a little more closely at the fire test itself. So standards such as UL 2079 and ASTM E1966 evaluate several critical performance characteristics. First, the system must prevent the passage of fire from the fire exposed side to the unexposed side. Second, it also has to limit the temperature rise on the non-fire side. And while the 400-degree threshold is often used as a general reference, the actual standard specifies that the temperature must not exceed 325 degrees above ambient. So if the starting ambient temperature is about 75 degrees Fahrenheit, the maximum allowable temperature rise would be approximately 400 degrees. After the joint assembly is constructed and the Firestop products are installed, according to the manufacturer's specifications, the entire assembly is then mounted to a furnace and exposed to a standard fire curve. Now, if the flame breaches to the non-fire side at any point during the test, or if the thermocouples on the unexposed side record a temperature rise exceeding 325 degrees above ambient, the system fails. Now, this test is an extremely demanding test, but interestingly, though, many experts would say that the temperature control is often the hardest part of the test, not the fire exposure itself. And the reason this temperature control is so important is that materials like cotton waste, for example, these can ignite at slightly or above 400 degrees Fahrenheit, even without direct flame contact. Now, this simulates real-world concerns where nearby items like carpeting, curtains, or even baseboards on the non-fire side could ignite from thermal heat transfer alone. Now, once the fire exposure phase is completed and the system passes both the fire and temperature rise criteria, the assembly is detached from the furnace and within a defined time window is going to be subject to a hose stream test, which we're going to discuss a little bit more shortly. Now, earlier I mentioned that the movement requirements for fire-resistant joint systems. Now, in modern building designs, it's important to recognize that joints are expected to move over time due to conditions like thermal expansion and contraction, wind-induced building sway, and seismic forces. And so because of that, Firestop systems have to be evaluated for how they perform under those movement conditions. The applicable test standard established for several movement classifications identified as level 1, level 2, and level 3, and each of these levels corresponds to a defined range of cycle counts and movement amplitudes, as you see illustrated here. Now, these categories, they're intended to represent the type of movement a joint may reasonably be expected to experience throughout the service life of the building. Now, it's also important that we want to keep in mind that, not every joint condition is treated the same. Some joints are expected to remain relatively static. Bottom of wall joints are a common example, and generally are not evaluated for dynamic movement. Other joints, however, such as head of wall conditions or vertical joints between unlike or dissimilar materials, these are going to be expected to accommodate actual building movement. Now, this becomes especially important in areas where seismic design is a factor. So when we refer to nominal joint width or installed joint width, UL defines that as the intended opening size of the joint as selected for testing. So in UL systems, as with other testing agencies, movement capability is typically expressed as a percentage of that nominal joint width. So to put that simply, the test measures how much the joint can compress or extend from its original installed width while still continuing to maintain its fire-resistant performance. So here we see a gypsum wall that's intersecting the underside of a concrete floor ceiling assembly. Now, in this case, the Firestop materials were installed at a nominal joint width of 1 inch, which represents the width of the joint opening at the time of installation. Now, during the cycling portion of the test, that joint is then going to be subjected to movement that's based on the performance level in the manufacturer's intended to qualify for. So in this particular example, the 1 inch joint is first compressed down to a 1/2 inch and then returned to its neutral or original width of 1 inch. Now from there, the joint is then extended out to 1.5 inches. Now this sequence demonstrates 50% compression and 50% of extension, which is going to confirm that the joint system can accommodate significant movement in both directions while still maintaining its fire-resistant performance. The purpose of this testing is to simulate the movement that the joints may experience in actual buildings. In the field, the joint can expand or contract due to thermal expansion, building sway, structural deflection, or seismic forces, and the test is going to help confirm that the joint system will continue to perform under those conditions. Now, to build in this idea, let's take a look at some of the traditional Firestop systems that have been used throughout the industry for many years. Now, they're sometimes referred to as encumbered systems, meaning their movement capabilities are inherently restricted by the physical characteristics of the materials involved. So, for example, Firestop sealants. Now, these are often acrylic-based smoke and sound sealants or spray-applied products, and they have a relatively dense material composition. Now, the number of solids present and the chemistry of the formulation directly influence how much movement the system can realistically accommodate. It doesn't necessarily mean that these products are inferior. They do remain code compliant and are widely used across our industry. However, they do have very practical limitations when it comes to joint movement. And in many situations, traditional sealant-based systems provide movement capability in the range of 25% compression and extension. And so you want to put that in perspective. A half-inch joint with a 25% movement rating would allow for approximately 1/8 of an inch compression and 1/8 of an inch extension, which results in a total deflection range of about 1/4 of an inch. Now, by comparison, you have the newer unencumbered fire stopping products that have been introduced in the recent years, and that can accommodate a significantly greater movement, in some cases up to 100%. So using that same half-inch joint example, these newer systems could provide a 1/2 inch of compression and a 1/2 inch of extension, resulting in a total movement capacity of 1 inch. Now, this additional flexibility gives designers and contractors more options when addressing conditions where joint movement is a major factor, whether that movement is caused by thermal expansion, structural drift, or seismic forces. The key takeaway here is that both traditional and advanced systems, they can meet the code requirements, but the important step during the design and installation is understanding the expected movement of the joint and also ensuring that the selected system is capable of handling those conditions. Now let's return briefly to the host stream test. Now, once a system successfully completes both the fire exposure portion and the temperature rise requirements, the next step in the evaluation process is the host stream test. Now, this test uses a 2.5 inch nozzle, and both the water pressure and the duration of the stream are going to be determined by the hourly fire rating of the assembly being tested. So, for instance, a 1 hour rated system is tested at a lower pressure and a shorter duration than assemblies with a 2 or 3 hour rating. So why is a host stream test included? Well, primarily, it's intended to evaluate the durability and structural integrity of the wall assembly and the fire stop system after exposure to fire conditions. So during a fire event, pressure is going to build rapidly on the fire exposed side of the wall, creating an imbalance with the cooler air on the opposite side. This host stream test is going to simulate that force, verifying that the components on the non-fire side remain secure and don't dislodge or fail. Additionally, during actual fires, elements such as ceiling tiles, suspended ceiling systems, and fixtures, these may collapse as the temperature starts to rise. So when those materials fall, they can strike the wall or the joint assemblies. This host stream test also helps simulate those kinds of impacts, ensuring that the Firestop system and surrounding construction remains intact. So in short, the host stream test serves as a durability and resistance evaluation, which confirms that the assembly can withstand fire exposure, pressure forces, and mechanical impact while continuing to protect the occupants and the adjacent spaces as required by code. So let's circle back for a moment to the topic of smoke and toxic gas movement. So as I talked about earlier, this component of fire protection is currently considered as an option portion of the fire resistance testing. It is not mandatory, and it is not a pass-fail requirement under ASTM E1955 or UL 2079. However, there are certain building types, particularly healthcare facilities, which include hospitals, nursing homes, and assisted living centers, that are now commonly required to incorporate smoke barriers as part of their design. Now, these smoke barriers, they may be installed either horizontally or vertically, and their purpose is to divide larger floor plates into smaller compartments that generally do not exceed 22,500 square feet. So for example, if a floor plan contains 45,000 square feet, smoke barriers may divide that space into 2 separate smoke compartments. Now, this design strategy supports what is known as a defend in place approach, which is critical in facilities where occupants cannot evacuate quickly or independently. So during a fire event, the occupants are moved from the affected compartment into an adjacent protected compartment. Now, smoke barriers are going to be required to do three things: resist the passage of fire, meet temperature rise limitations, and increasingly restrict migration of smoke and toxic gases. Now, to evaluate smoke leakage performance, UL developed the L rating test. Now, this test measures the amount of air leakage through a Firestop system. Now, air leakage serves as a practical indicator of potential smoke movement, and this rating is now commonly applied to joint and penetration Firestop systems used in smoke barrier assemblies. Now, in addition to healthcare facilities, correctional institutions, this is another building type where the defend-in-place strategies are common. Now, in both of these environments, the L rating has become an important requirement for Firestop systems used within smoke barriers. Although the L rating is not yet required for all construction types, there is a growing awareness and interest across the industry. So whether it eventually becomes a universal requirement, honestly, that still remains uncertain. But in high occupancy buildings where evacuation is going to be difficult, it does represent an important advancement in life safety protection. So next, let's shift our focus over to what the building code says regarding special inspections. So in 2012, the International Building Code introduced special inspection requirements for Firestop systems for the first time. Today, those provisions can be found in the IBC section 1705.16, which outlines when these inspections are required and how they should be performed. Now, in general, special inspections are required for specific types of construction, and these are going to include high-rise buildings, risk category 3 buildings, which typically involve large groups of occupancy, risk category 4 buildings, which are going to include essential emergency facilities, and beginning with the 2018 code cycle, certain group R residential occupancies, housing more than 250 occupants. Now, when this portion of the code has been adopted by the local jurisdiction, these building types must also undergo special inspections of fire-resistant penetrations and joint systems. The purpose of these inspections is to verify that the Firestop systems installed in the building match the tested and listed assemblies specified in the design documents, and that they've been installed correctly and in accordance with those system requirements. And we'll take a closer look at how these inspections are performed in the next slide. Now, under the special inspection provisions, the authority having jurisdiction, or the AHJ, is responsible for approving a qualified special inspector. And once designated, that inspector evaluates the Firestop installations using established industry standards, specifically ASTM E2174, which is going to apply to penetration Firestop systems, and ASTM E2393, which applies to fire-resistant joint systems. Now, ASTM E2393 is going to provide two primary methods for inspecting fire-resistant joints. The first method is a visual inspection. This is going to require the inspector to randomly observe 5% of the total linear footage of each joint system while the installation is taking place. The second method is a post-installation destructive testing. Now, this is where one sample of each joint system is physically tested for every 500 lineal feet installed. And it's important that we want to pay attention to the phrase each joint, because this is often overlooked. Within a single room, it's very common to encounter multiple joint types. And these are going to include head of wall joints, bottom of wall joints, vertical joints where drywall meets concrete or CMU, vertical joints within the wall field, and joints at the wall intersections or bulkheads. Now, each of these joint types, they have to be inspected separately according to the chosen inspection method. The standard also requires that the inspection be repeated for every 10,000 square feet of that building's footprint. So on larger projects with many joint conditions, this can quickly become a substantial inspection process. And so for that reason, it's important to plan for inspections early in the construction schedule so they can be completed without disrupting project timelines. Finally, we always want to verify with the local building code and the AHJ, because while many jurisdictions have adopted these provisions, others may not yet be enforcing them. Now, first generation Firestop systems began appearing in the industry in the late 1980s and early 1990s. Now, these early products were typically described as wet applied systems, which include sealant and spray applied materials introduced in the construction industry and began to recognize the importance of proper fire stopping. Now, many of these products are acrylic based, particularly when used as sealants, although some silicone based options are available as well. Now, the movement capability of these systems depend largely on the underlying formulation of the material. In general, silicone sealants tend to provide greater flexibility and movement capacity as compared with acrylic products. And although system performances can vary depending on the specific manufacturer and the system design. Now, the image shown here illustrates a common head of wall joint where a gypsum wall meets the underside of a concrete deck. In terms of installations, the Firestop sealant must be installed at the specified depth and thickness indicated in the manufacturer's UL system listing. The main takeaway is that the movement capability is product specific. So when selecting a Firestop solution, it's always important that you want to review the tested and listed systems to understand the movement limitations, particularly in conditions where joint deflection is an important design consideration. Another product type that has become widely used in this category is Firestop spray. Now, this has seen a significant adoption throughout the industry. And while these systems are most commonly used with fluted metal deck conditions, can also be applied in certain concrete deck applications as well. Now, these systems generally include a packing material, typically mineral wool, which is first installed into the joint opening. After that, the backing material is in place. The Firestop spray is going to be applied over the exposed face of the mineral wool in accordance with the requirement of the tested system. Now, in many cases, the spray is installed at a wet thickness of approximately 1/8 of an inch, which typically cures and dries to about 1/16 of an inch. Now, because of the nature of these materials, spray applied fire stopping products may allow significantly greater compression and extension than standard sealant systems, although the movement capability is really still going to be dependent on the nominal joint width. So in the example shown here, the nominal joint width is going to refer specifically to the opening between the top of the gypsum board and the underside of the fluted metal deck, not the total depth of the flute itself. That joint width is often in the range of a 3/4 inch to a 1 inch, depending on the assembly design. The filled flute area in the center should not be included when you're determining the nominal joint width. Now, this distinction is going to be very important because the testing standards are designed to apply the greatest stress at the narrowest portion of the joint where the Firestop material experiences the most demanding conditions during both the movement cycling and the fire exposure. So for this reason, system performance is evaluated at the primary stress point rather than across the entire depth of the deck flute. Now, over the past several years, we've continued to see advances in Firestop solutions, particularly driven by the need of specialized building types. And one of the most prominent examples right now being data centers. Now, these facilities often require significantly greater movement capacity at the head of wall joint, sometimes reaching up to 4 to 5 inches of total deflection. So to address these conditions, the industry has introduced innovative framing approaches, including what are commonly referred to as T-shaped tracks or mushroom tracks. Now, these systems represent one of the earlier approaches to develop to manage high movement joint conditions. And although the concept itself has existed for some time, demand for these types of systems have really increased as more high performance buildings are constructed. And T-track assemblies remain code compliant and are widely available. The design incorporates a horizontal shoulder that supports the gypsum board while allowing it to move within the track, and the metal cover plates are then installed across the face of the gypsum board and are either contour cut to match the fluted metal deck or flat cut for concrete decks. And one of the primary advantages of these assemblies is that their enhanced movement capability, with many systems capable of accommodating up to 100% of compression and extension. So as a result, these can be an effective overall application where significant head of wall movement is anticipated. Overall, these systems represent a practical and tested option for addressing the increased performance demands as seen in modern construction projects. Now, as the industry has continued to evolve, we've also seen a growing shift toward what many refer to as the next generation of Firestop solutions, particularly preformed fire stopping products. And today, several of the manufacturers offer a variety of these systems, each one of them designed to address installation efficiency and performance consistency. So unlike wet applied materials, these preformed products are fully cured at the time of installation, which is going to remove many of the variables associated with job site mixing, curing conditions, and application thicknesses. Within the CEMCO fire stopping product line, for example, these materials may be foam-based or vinyl acrylic-based, and many incorporate an intumescent strip as part of the production design. So for those of you unfamiliar with the term intumescent, it basically refers to a material that expands when exposed to heat. And a very simple analogy that many people recognize is the small novelty fireworks, sometimes called snakes, which expand and grow as they burn. The same basic concept is going to apply to our products. When exposed to elevated temperatures during a fire event, the intumescent component expands and seals the joint, preventing passage of fire and smoke. Now, although it's not visible in some of these images, the photo on the lower right corner shows fire gasket, which is one of CEMCO's preformed fire stopping products. Now, on the back side of the vinyl flange, there's an integrated intumescent strip. So when exposed to fire conditions, that strip expands into the joint cavity, helping maintain the fire resistance rating while also allowing for joint movement. Now, these systems offer a cleaner and more controlled alternative to traditional wet applied fire stop installation. Now, this slide shows an example of fire gasket installed in the field, providing a clear view of how the product functions during installation. Now, the gasket includes an adhesive back flange that attaches directly to the vertical leg of the track, and this can sometimes be installed, or this can be installed actually, on either slotted track or solid track configurations. Once the gap is in position, the gypsum board is installed over the product and typically centered along the track leg to ensure a consistent coverage and performance. The fire gasket is going to be available in 3 standard sizes: 1/2 inch, 1 inch, and 1.5 inches. And it's going to be suitable for both 1 hour and 2 hour rated wall assemblies. Now, you may have just noticed that there is the instruction sequence that the system also allows for drift and dynamic movement, which makes it a very strong option for projects where structural movement must be accommodated. Now, this could be particularly useful in seismic regions where joint movement is expected and the fire stop system must be capable of maintaining performance under those conditions. Now, in addition to total systems like fire gasket that attach directly to the track, there are also next generation solutions that integrate with drywall finishing accessories. And one example of this is Hot Rod XL, which is shown in the images on the slide. Now, this product includes a perforated L-bead leg that is installed onto the face of the gypsum board. So positioned within the joint is a compressible foam gasket along with an integrated intumescent strip that expands when it's exposed to fire conditions. And one of the advantages of this type of system is its ability to provide both a fire-resistant performance and a finished drywall edge. Now, that becomes especially useful in buildings with exposed ceiling conditions, such as hotels, apartments, or residential towers where the structural deck remains visible. So in these types of designs, the deck serves as the final ceiling surface, making the joint between the wall and the deck visible to occupants. The L-bead edge helps conceal exposed drywall edge and creates a clean transition at the joint. So after installation, the bead is stapled and finished with joint compound, and a zip strip is removed to reveal a crisp finished edge. The result is a system that provides a code-compliant fire protection, joint movement capability, and a clean architectural finish. Now, these systems can also contribute to meet STC sound performance requirements, making them particularly useful in multifamily and hospitality construction. Now, let's also take a moment to review a more recent code development. So in both the 2018 and 2021 editions of the International Building Code, section 715.6, this was introduced and further clarified. So this section addresses the treatment of vertical joints where fire barriers intersect the exterior building facade, such as a glass curtain wall interface. So to comply with this requirement, several manufacturers now offer tested solutions for these conditions. And the system shown here is one example. CEMCO is tested to the UL 2079 standard, which is the current benchmark referenced by this code. Now, while UL 2079 remains the most widely used test method today, an ASTM work group has developed a new test method that has been presented to the ASTM E05 committee, and this is currently under review. Now, once adopted, the manufacturers will likely retest the applicable systems to align with the updated standard. Now, the solutions shown here incorporate CEMCO SuperSeal X, which in this case is provided in a black profile to better integrate with the curtain wall assemblies. Now, behind the SuperSeal X is a metal L angle, which is fastened to the final vertical stud, extended outward toward the glazing while maintaining approximately a 1/4 inch gap from the curtain wall. Now, the SuperSeal X includes a bubble gasket profile that compresses against the curtain wall, which creates a clean and discrete interface. That black finish, it allows it to blend visually with the curtain wall framing while still delivering a 1 hour or a 2 hour fire resistant rating, along with tested STC sound performance. So this type of system helps satisfy both fire resistance and acoustical requirements, while at the same time maintaining a visual transition between the fire rated wall and the building facade. Now, let's look at Fire-Rip. So this product was developed in response to the increasing demand for high movement fire rated joint systems, particularly in large infrastructure projects such as data centers. And as we discussed earlier, the T-track assemblies can be used to accommodate large deflection ranges. However, they do present some logistical challenges because each T-track has to be manufactured to match the specific stud width being used. So whether that's a 3 5/8 inch, 4 inch, 6 inch, or 8 inch framing. Now this means that different track profiles must be produced and stocked for each wall configuration. Fire-Rip, by comparison, offers a very similar movement capability, up to 4 inches of total deflection, but with a lot greater flexibility during the installation. Because it's surface mounted, it can be installed with virtually any standard track, whether it's slotted or solid, and it does not depend on the stud width of the assembly. Now, this versatility allows it to be used across multiple types of assemblies, including CMU walls, shaft walls, and traditional gypsum partitions. It's a single profile system that attaches directly to the underside of the deck, and it simplifies both the installation and the material inventory. So in this image, it shows the lower left-hand corner. You can see Fire-Rip installed beneath a fluted metal deck. And one benefit of this system, and others within our product line, is that when used with mineral wool insulation, the UL system allows the mineral wool to be compressed into the deck flutes without requiring any additional sealant or spray coatings over the face. The manufacturer of Fire-Rip focuses not only on meeting code requirements, but also on developing solutions that are going to reduce labor and simplify installation in the field. And because of our close relationship with the drywall industry, CEMCO is really going to place a strong emphasis on solutions that are going to provide both code compliance and labor efficiency. And Fire-Rip is one of those examples of how we're working to achieve that balance. Now, let's shift away from specific product solutions for a minute and talk about something that often has much impact in the field, and that's going to be construction documents. So what you see on this slide represents a fairly typical partition detail that might appear in an architectural drawing set. And in many cases, designers are going to include an exploded or sectional view similar to this one in order to show the structural components, joint conditions, and general construction sequence. Now, these drawings usually contain several call-outs or reference notes that direct the reader to additional details located elsewhere in the document set. And those references are going to help clarify how the assembly should be constructed and how particular conditions, such as joints, should be treated. So from a design perspective, these details play an important role in communicating not only the structure of the wall assembly, but also the expected joint conditions and the performance requirements associated with those joints. When those details are coordinated well, they help reduce confusion in the field and allow contractors to install systems that match the intended design. Now, this next example comes from a project that our product manager was involved with a few years ago, and it basically highlights an issue that we occasionally see in construction documents. So in this particular drawing set, the designer had indicated a 3/4 inch joint width for a non-rated or smoke partition, while the rated walls on the same sheet were shown with a 1-inch joint width. So additionally, elsewhere on the drawings, there was also a CMU header wall detail showing an 1.5 inch joint. And at first glance, each of these details might appear reasonable on its own, but the problem is going to occur when these different wall types intersect within the building. So for example, in a non-rated wall with a 3/4 inch joint intersects a rated wall designed for a 1 inch of deflection, that smaller joint opening can act as a physical bump stop. So when that happens, the rated wall may no longer be able to move through its full design deflection range because of the adjacent wall limits to that movement. So from a design standpoint, the recommendation that we often provide is that we want to standardize the joint widths and movement details across wall types whenever possible. So by coordinating these dimensions, designers can help ensure that when different wall assemblies intersect, none of them restrict the movement of the others. And this helps preserve the intended deflection capability and ensures that the wall assemblies performed as designed. Now, continuing with the topic of construction documentation, let's talk briefly about specifications. So the most commonly used specification section for fire-resistive joint treatment continues to be section 078443 and 078446, both of which address joint fire stopping within the building. Now, more recently, we've also begun to see some projects use 078400 as a broader category that covers both fire stop penetrations and joint fire stop systems within a single section. Now, even with that shift, however, 078443 and 078446 remain the most widely used sections throughout the industry today. Now, another specification that has seen some evolution is section 079200, which traditionally covers joint sealants. Now, historically, acoustical sealants used within interior wall assemblies, those were often grouped under the same section requirements for exterior sealants, such as weather exposure, UV resistance, and adhesion, and are quite different from those as interior acoustic or smoke sealants. So as a result, we're now seeing a greater specificity in some specification sets, including sections like 079219 and 079216, which are written specifically for acoustic joint treatments. Now, we're always happy to support design teams as a technical resource when it comes to developing partition head details or specification language. And while we certainly do welcome the opportunity to have our product specified, we also recognize that some projects require non-proprietary specifications. So in those situations, we at CEMCO, we're glad to assist with performance-based specification language for preformed joint solutions, regardless of who the manufacturer is. Now, another topic that frequently comes up during discussions like this is sustainability, and specifically whether Firestop products can contribute to LEED certification. The short answer on that is going to be maybe. It depends on the specific product and manufacturer. And for many wet applied Firestop materials, the formulation must remain tightly controlled in order to meet the UL follow-up service requirements. And so because those materials are chemically sensitive, manufacturers often have limited flexibility when it comes to incorporating recycled content. With preformed fire stopping products, there may be a greater opportunity in some cases. So for example, with portions of the CEMCO product line, the vinyl flanges and the foam components, these are not part of the fire resistive elements of the system. And so because of that, these components sometimes include recycled content, which may contribute towards sustainability goals on certain projects. Now, that being said, regardless of the manufacturer being considered, it's always best you want to consult directly with the manufacturer to confirm whether a product can contribute to LEED credits or sustainability documentation for a particular product. So to wrap things up, the goal of today's presentation really has been to walk through some of the key concepts and evolving technologies within the field of joint fire stopping. We've discussed how building codes address fire-resistant joint systems. We've reviewed the applicable test standards and looked at how joint movement, inspections, and smoke control considerations factor into system performance. We also have explored the progression from traditional wet-applied Firestop systems toward the newer preform solutions that are becoming more common in modern construction. Now, these newer systems are gaining traction because they can offer advantages in terms of installation efficiency, consistency, and movement performance. At the same time, it is important to remember, though, that both the traditional and the newer approaches can meet code requirements when they are used correctly. And the most important consideration is ensuring that the system selected during design, specification, and installation matches the performance requirement of the project, that they accommodate the expected movement of the building, and ultimately contribute to the overall safety and durability of the structure. So with that, I'd like to thank everyone again for taking the time to attend today's session, and be happy to hand it back off to Tao and answer any questions that you might have.
Thank you, Jaime. Couple of questions here. Are there solutions for mechanical, electrical, and plumbing penetrations through joints?
Yes, there are, but please understand that penetrations through the joints may impact the movement capabilities of that joint. And so we recommend that you have a no-fly zone for all wall penetrations to be a minimum 1 inch below the fully open position of the joint.
Great, thank you. Another question, how do data centers differentiate from other construction projects in terms of fire stopping and movement capabilities?
Yeah, that's a great question. Some of these types of structures really call out some of the highest deflection parameters in the industry today. And, the need for products like, let's say, for example, the CEMCO Fire Rip, these address high movement coupled with the fire stopping capabilities. So the technology of these buildings is requiring a lot more movement capabilities.
All right, one of our attendees said you noted that for these systems, they are product specific for the manufacturer of the sealant. Is it also product specific for the gypsum board or the slotted track?
That you would refer to the UL directory, and in that you would go to product, UL product IQ, and that would provide a list of either fire sealants manufacturers or preform product manufacturers like ourselves, which systems products could be used in those systems. Sorry.
All right, and last question here. What attributes are you finding fire-resistive joint products are required to provide today?
A few actually. We have sound and acoustic performance that address STC. We have code compliance for fire and temperature. We have movement. And then lastly, we have to address aesthetics. So those are the 4 primary areas that we want to cover today.
Well, that question concludes our Q&A portion. Thank you so much for your presentation, Jaime. Thank you to CEMCO for sponsoring this webinar, and we appreciate everyone being here today. Have a good rest of your day, and we'll see you next time. Bye now.